This is Mac 1105, section, Chapter 4, Section 2, Linear Functions. This is a real short section, so this will be a short video. Basically, it's dealing with what we call scatter plots and statistics. And this is information about on-base percentage and runs scored for some major league teams, I think in, I can't remember what year it was, but in some year. So here's the ordered pairs that we plot. And this is on page 392 or 292 of your textbook. And here's the scatter plot that we get. And if you use a calculator, there's that too. I'm not going to be so much concerned with showing you how to do this with a scatter plot. If you take statistics, you can do this. Some things you need to understand about scatter plots, though, is that scatter plots, in mathematics, the lines line up perfectly, the points line up perfectly. In statistics, because it's real world data, it doesn't line up perfectly. So what we do is look for a pattern. So if we have a series of points that do this, we call this a positive linear relationship. The points do this, as we call this a negative linear relationship. This is not a linear relationship. Any set of points that has a curve or a point is not considered linear. Same thing with letter D there, it's not linear, and same thing with letter E. They're not considered linear. If you look at example 2, letter A would be negative linear, B not linear, C not linear, and then D not linear. Okay? Now, one of the things that we do with this, and they're doing the same thing, is we still use point slope. We use slope and point slope to get an equation. So what they've done here in example 3 is they've picked the points 31.5, 60, 690, 33.1, 778. So here's your x1, y1, x2, y2. When you stick it in the slope formula, you get a slope of 55. If you take that slope of 55 and put it in for m, and they're using the point 31.5, 690, you could have just as easily used 33.1, 778. They put it in point slope, do the math, and they get an equation that satisfies the data, but it's not exact. It's what we call a good estimate of the data. It's called a linear regression equation, least squares regression equation, which means it's a good predictor, but not a perfect predictor. The last thing I want to mention here, and this is it on this one, is that, if you do plot that line, y equals 55x minus 1042.5, you'll see that the line doesn't hit all the points, but it's called the best fit line because it is the line that has the shortest perpendicular distance between every point. See, if you were to take this line and move it, take the line and move it this way, you'd be increasing your distance here and somewhere here, but decreasing some. If you did it this way, you'd be doing the same thing. This line right here has the most amount of points that hit the line, but also has the least perpendicular distance between the other points. And that's what we call by best fit line for real world data.